Okay, we'll begin with the first problem set on areas and volumes. And we're looking for the region in the first quadrant bounded by the x-axis and the curve 2x minus x squared. In these kinds of problems, if you can, you want to make a simple graph. It doesn't have to be extremely accurate, but as good as you can get. Now there may be, if you have a calculator problem, then I would definitely graph it on your calculator, and I'll show you some of that in a minute. Well, this function factors as x times 2 minus x, so we have zeros at 0 and 2. And the vertex is at 1, comma 1. And the first thing that we're looking to do is to find the volume produced when R, which is that area bounded by the curve and the x-axis, is revolved around the x-axis. Okay, and when we take a representative strip there and we revolve it around the x-axis, we end up with these disc-shaped cylindrical cylinders. Okay, the area of those cylinders are pi r squared, and the volume are pi r squared h. And the total volume is going to be the sum of all of those individual discs. And so writing the integral for this is going to give us the volume is equal to pi times the integral from 0 to 2 of 2x minus x squared entire quantity squared dx. And the way we're going to have to evaluate this is to square this particular integrand out, which leaves us with pi times the integral from 0 to 2 of 4x squared minus 4x to the third plus x to the fourth. Integrating that, we get that the antiderivative is 4x to the third over 3 minus 4x to the fourth over 4, which is minus x to the fourth, and then plus x to the fifth over 5. And we're going to evaluate that at 2 and subtract from that the expression evaluated at 0. Evaluated at 0 here, we can see the entire thing will be 0. And the rest of that is just finding a common denominator at that point, which would be 15ths. And we get pi times 160 15ths minus 240 15ths plus 96 15ths. And that ends up as 16 pi over 15. So that's part A, finding the volume when R is revolved around the x-axis. For part B, we're going to take the same thing and revolve it instead around the y-axis. Okay, I'm going to scroll this up and we'll go on to part B. Okay, this time when we're revolving around the y-axis, we're going to use the cylindrical shell method. And so we take a representative strip and we're going to spin that around the y-axis, and this time we end up with a can shape or a cylindrical shell. The surface area of a cylindrical shell is 2 pi RH, and to give it some volume, we're just going to make that shell a little bit thicker. We'll add some dx to that. Alright, so the total surface area then, or the total volume of that object then, will be all of those cans added up together. And that will be 2 pi times the integral from 0 to 2. The radius in this case is the x value for each particular representative strip. And the height will be the height of the cylinder, which is the height from the curve to x. In this case, that's 2x minus x squared, the function itself, and the thickness will be dx. Before we integrate, we can multiply out that x, and we're ready to integrate. We get 2x to the third over 3 minus x to the fourth over 4, and the limits of integration are 0 to 2. We're going to evaluate that at 2 and subtract from that the same thing evaluated at 0. The second one will be 0. And so we get 2 pi times 16 thirds minus 16 fourths, that quantity minus 0, and that gives us, and the n will be 8 pi over 3. Alright, so that's part B of that problem.